Advanced Algebra, Chapter 7, Lesson 6. And we've been looking at combining functions algebraically: addition, subtraction, multiplication, division. We're also going to look in future lessons at combining functions by composing them, and we're also going to look at getting or creating a new functions by looking at the inverse of a function. And all of these methods are ways to create or to arrive at new functions from other functions. And we've also looked at determining the domain of functions. And what I want to talk about here real quickly is the fact that these resulting functions, the domain of these resulting functions, inherit some of the characteristics of the functions from which they came. In other words, when we combine functions, the resulting function's domain we can't simply determine by inspection or by doing the same method that we did with the original functions, looking at division and looking at a radicand. These new functions, because they came from other functions, inherit some of the characteristics of those old functions, and that affects the domain of the new function. So we need to know how these new functions are affected by the original function's domain. And the first set that I want to look at are functions that are combined algebraically. So for functions that are combined by adding, subtracting, multiplying, or dividing, the functions, the domain of the new function is determined by the intersection of the two original functions. So what I'll need to do is to know what the domain of the first two original functions are, and then I'll be looking for where those functions' domains overlap. And where they overlap, that will be the domain of the new function. So the new function inherits the values from the domains of the two original functions. The only additional step that I will look at then is if I'm dividing functions, the new function's domain, its denominator can't be 0, so I will have to look at that in addition to the intersection of the two original. Okay, so let me describe that or show you here real quickly what that looks like, or just to sum up what I just said, and then we'll do a couple of examples. So to determine the domain of the new function that comes from an algebraic combination, adding, subtracting, multiplying, or dividing, you need to determine the domain of each original function first before you apply the algebraic operation. The domain of the resulting function then will be the intersection of those two domains. With the additional thing that we have to look at is if we're dividing functions, that the denominator function cannot be 0 at any point. So let's quickly look at this example. I'm given two functions and I want to add and subtract them and then find the domain of the resulting function. So I want to determine the domain of each function first. Well, the f function, because there is no division and there is no radicand, the domain of that function is going to be all real numbers. And if I was to graph that or give a graphical representation, that would be the number line that goes in both directions. The g function's domain, again, does not have any division, no radicand, so it also has a domain of all real numbers and would be this. And then what I would look for would be where these two lines overlap. Well, because they both go on in both directions forever, they overlap everywhere. So the domain of the new function is going to be all real numbers as well. And then if I was dividing, I would check the denominator to make sure it wouldn't be 0. Because I'm adding these, I would simply add these functions together. So the 3x and the 2x would be 5x, the 8 and the 12 would be -4. We've already done that function before. And so we would get 5x minus 4. And then if I subtract them, again, making sure I apply the negative sign to both terms of the second function, I would get x plus 20, and the domain would be all real numbers because that would be the intersection of both. Okay? Let's take a look at multiplying and dividing. So before I multiply or divide these functions, I want to look at the domain of both. So again, if I look at the f function, because there is no division and no radicand, the domain of the f function is all real numbers. If I look at the g function, because there is no division and no radicand, it also is all real numbers. And then the intersection of those then would be all real numbers, because both of those contain all real numbers. Okay? Now, the only thing I'll have to do with this all real number set is whatever function ends up in the denominator, whatever makes that denominator 0, would be excluded from the domain of the resulting function. So let's go ahead and, well, let's look at, if we multiplied the functions together, we simply multiply those two functions together. We've already done that, so this would be the resulting function with a domain of all real numbers. Now, if I'm dividing, I'm going to do the f function divided by the g function. So the g function is going to be in the denominator. So that gives me x squared minus 1 over x plus 1. Now I want to look at the domain here before I do any more simplifying, because this denominator cannot be 0 right here. So I cannot use negative 1. So that means we have to adjust the domain from the intersection to making sure that we don't use this number negative 1, because that makes the denominator 0 here, and I can't have that. So then I would go ahead and do my simplification process. That's the difference of two squares, so I would factor that, and you always want to look to factor every quadratic in order to simplify, which allows me to do this. So the resulting function, f divided by g of x, is x minus 1. Now I want to make a point here. You'll notice that if I wait till here to determine the domain, the intersection of which is all real numbers, I would leave it as all real numbers, because in the final simplified version there's no denominator and there's no radicand. However, we have to understand that this function came from another function. It came from this function. So whatever characteristics this function has, it inherits that all the way through, even though this ends up being reduced out. Because this function came from this one, it inherits the characteristics that this function cannot be negative 1. So that's why it's important to look here for my restrictions before I simplify, to make sure I see the inherited characteristics that I need to carry through. So don't wait until you do all the simplification and then get down to here, because if you look here, you'll say, well, there's no division, there's no radicand, must be all real numbers, not recognizing that this function did come from another function. Okay, so this would be the function cannot be negative 1. Okay, so I'm going to go ahead and do one more example on the next page. If you want to check that out, it's similar to the one we just did here, where we have to be careful to look at the characteristics of the function all the way through and not just wait until the end. I'm going to take a look at number 18 here, where we have g function divided by f function. And again, before I determine, or before I start to do the operation, I want to figure or determine the domain of each function to begin with. The g function is in the numerator, and the g function is x minus 1. There's no denominator, there's no radicand, so that's all real numbers. The domain of the f function, again, no division, no radicand, all real numbers. Therefore, the intersection of these two is going to be all real numbers. Now, because I'm doing division, I will have to make sure that the function that's in the denominator does not equal 0. So if I go ahead and put the functions together to begin the process, whoops, I did that wrong. I'm doing the g divided by f, so let me back that up a little bit. One more step. Okay. We're doing the g function divided by the f function. So the g function is x minus 1, and the f function is 2x squared plus x minus 3. Now, before I go any further, because I have a denominator here, I want to find out what the restrictions are right here before I go further. Now, this factors, so I'm actually going to have to go one more step. This ends up being 2x, and then let's see, I got to factor this. So this is going to be x, so this is going to be plus 3 and minus 1. No, that's not right. This is going to end up being minus 1 and then plus 3, I think. So 2 and then 3, yes, that's right. Okay, now this is going to help me determine what makes this denominator 0. This is just like finding the zeros of a quadratic. So the number positive 1 makes this factor 0, and the number negative 3/2 makes this one 0. So my intersection domain is going to have some restrictions to it because this denominator function cannot be 0. So x cannot be then negative 3/2, and it also cannot be 1. Then I can go ahead and finish reducing this, so I end up reducing those out. So the g function divided by f function resulting simplified function is 1 over 2x plus 3, and my domain would be all real numbers as long as it's not negative 3/2 and not 1. Again, if you waited until you got here to determine that domain, you would miss out on this restriction right here, which continues to be inherited by this function because this function came from this the combination of these two functions.